So, good afternoon, everyone. Today we will discuss a very important topic, kinetic theory of gas and thermodynamics. It is a basic fundamental topic of modern physics in our modern daily life, a gaseous structure and a gaseous molecules, the path of gaseous molecules, how we will done and how we will conclude the temperature of the molecule and etc. etc. So we know the Joule's law in class 9. In class 9, we will say that the total heat is converted the work, but this is a totally wrong. In this thermodynamics first law, we will say that the Joule's law is totally wrong and the thermodynamics first law and the other kinetic theory of gas is accordingly right to the modern physics and modern daily life also. So our first topic, kinetic theory of gas, is based on some following basic assumptions. And these are the fundamental properties and these are fundamental of this chapter. So let us take the first point. A gas is consist of very large number of molecules. These molecules are identical, perfectly elastic and hard spheres. Just say these words, a gas consists of very large number of molecules. These molecules are identical, perfectly elastic and large spheres. So second point, molecules do not have perfectly directions of motion. Molecules are random. The motion is completely random, like as molecule moving according to x-axis, according to y-axis and according to z-axis also. They are not perfectly motion and not perfectly obey the any axis law. The molecules travel in straight lines and free motion of most of the time. And the time of the collision between 2 points and two molecules is very small. And this time is called collision time or low action time. This time is very, very small. Fourth point, the collision between molecules and the wall of the container is perfectly elastic. See, collision are two types. Okay. Collision are specially two types. One is perfectly elastic and another is perfectly inelastic collision. So this collision is perfectly elastic collision. It means kinetic energy is conserved in this collision. Fifth, the path traveled by a molecule between two collisions is called free path. And the mean of this distance traveled by a molecule is called mean free path. Sixth, the motion of the molecule is governed by Newton's laws of motion and respectively Newton's second law and Newton's third law of motion. And last but not least, the effect of gravity on the motion of molecule is very, very negligible, very, very. So according to my suggestions, please note down and please remember third point is very, very important point and fourth point. These are important point according to NEET and JEE purpose because many problems are solved between 2 points. So this is the expression of the pressure for the pressure of a gas or gaseous molecule. At first, starting this topic, expression for the pressure of a gas, so we'll conclude the momentum of a particle. Do you know what is the momentum of a particle? Momentum of a particle means mass into velocity of the particle. It is a scalar or vector quantity? Yes, this is a vector quantity. Let us see the particle M in the center of when the particle is strikes in the CB wall, this container and the wall is CB, and when the particle strike back from the before wall, then the velocity direction changes, right? So momentum is changes. So I know that so v square equal to vx square plus vy square plus vz square. How is this? So we can represent it r vector equal to xi cap plus yj cap plus zk cap. So v square equal to vx square plus vy square plus vz square. So the change in momentum of the molecule after one collision. Let us see molecule collide with another molecule, and after one collision with wall BCHE, this wall, this right hand wall BCHE. So the change in momentum mvx1. So according to x-axis direction, so mvx1 minus or minus mvx1, so 2mvx1. So particle collide with the uniform velocity, right? So we know that uniform velocity formula is S equal to Vt. So the time taken between successive impacts of the phase BCHE is distance by velocity. So distance is L plus L. L is the length of this total length and the total face of each length. Okay. So the time taken distance by velocity. So L plus L means 2L divided by Vx1. So the rate of change of momentum due to collision. How? Rate of change of momentum means change in momentum divided by time taken. Rate of change of momentum means change in momentum by time taken. So 2mvx is the change of momentum and the time taken equal to 12 by vx1. So formula equal to mv x1 square by L. So total force F is equal to mvx square by L x1 square plus mvx2 square by L plus mvx3 square by L plus dot 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 mv x1 xn square by L. So m by L vx1 square plus vx2 square plus vxn square. So this is the term vx square plus vx2 square plus vx3 square and so on. Vxn square is nothing but the mean square average velocity. We'll discuss the term in the after some topics. So m n by L summation, this is square velocity, mean square velocity of vx square. So since molecules do not favor any particular direction and we denote the system is an isotropic system. So Vx square equal to Vy square equal to Vz square. But V square equal to Vx square plus Vy square plus Vz square. Because total vector equal to V R vector equal to x square plus y square plus z square r square equal to. So V square equal to V x square plus Vy square plus Vz square. So mean square velocity, that means Vx square mean is equal to V square by 3. So pressure is equal to the force divided by area. We know that from according to this law, P is equal to F by A. So Fx by L square. So F means total m into n means this is the n equal to total number of molecules and small f equal to mass of one molecule. So small m into capital M equal to capital M. Capital M is the total mass of the gas. So m by 3L cube and into mean square velocity. So m by 3L cube and L cube means volume. So m by 3V into V square. So hence where L cube is the volume of the container is V and m equal to total mass of the gas, C square equal to mean square of the velocity. So P equal to 1/3 rho V square, right? So please note down this formula and remember this formula because this is the important part. P is equal to 1/3 rho V square, and If you take SLR books or any other books, you can see also P is equal to 1/3 rho C square also. According to ideal gas system, we know that for n-mole gaseous system, PV is equal to nRT, right? So total translational kinetic energy half mv square. So equal to 3 by 2 PV equal to 3 by 2 nRT. This is the formula. Total translational kinetic energy of a gas equal to 3 by PV, and we know that PV equal to nRT, so 3 by 2 nRT. So translational kinetic energy of one molecule, so equal to 3 by 2 kT, where K is the Boltzmann's constant, and it is the independent of nature of gas. And one that is a unimolecular, is a dimolecular, is a trimolecular, etc. Polymolecular. So this does not depend. It is only depend on the independent of nature of gas, and it is only depend on temperature and the number of moles and Boltzmann's constant. Nothing like that. So from this equation, P equal to 1/3 rho V square, and we know that V square equal to 3P by rho. So V RMS means root mean square velocity of the gas. So V RMS equal to root over 3P by rho, and P by rho equal to 3RT by M. So this is also, please note down, when we will use capital R, then use the molecular formula of the mass, and when we use the Boltzmann's constant, then we will use the small m, like a 16 gram O2. So when we use capital R, so please use 32, and when you use the KB, Boltzmann's constant term 1.3 10 to the power minus 23, then use a 16 gram. This is the difference. Please realize the difference between the capital and smaller relation. So pressure exerted by the gas P is equal to 1/3 rho V square. That means 2/3 into half. Just simplify it. Half rho V square means E. So P is equal to 2/3 of E. So this is the important. So E is equal to 3 by 2 of P. So the total translational kinetic energy per unit volume, so V equal to 1, it is called energy density of gas, is numerically equal to 3 by 2 times of pressure exerted by the gas. Important points: VRMS proportional to root T, and these are very, very important. And also VRMS proportional to 1 by root over of capital M. This is also important. And also VRMS proportional to 1 by root over of small m, right? At absolute zero, the motion of all particles of the gas stops. So this is the Maxwell distribution law, a plot of dnV by V. So the number of molecules per unit volume. This just remember this plot dnV by V. This is the Vp, probable velocity, most probable velocity, and V bar is the average velocity, and RMS is root mean square velocity. And from VRMS greater than V bar greater than Vp, please use remember this curve. Okay. So average speed V bar equal to root over 8 kbt by pi small m, or this is equal to 1.59 root over 8 kt root over kt by m. Derivation is not in our course. Okay. So please just remember the formulas for NEET and JEE Mains purpose. Don't remember the other things. So VRMS equal to root over 3 kt by m, root over 3 RT by capital M, or most probable speed Vp equal to root over 2 kt by small m. So degrees of freedom means. So degrees of, what do you mean by degrees of freedom? Is a very important topic in our scenario. So degree of freedom. At first, we'll consider a circle which is rolling about the x-axis. So how many axes to discuss the motion of this circle? Only one axis. Okay. So when uh, a- just a particle moving along the xy plane, then two axis is introduced to describe the motion. So degrees of freedom is the total number of independent coordinates. Total number of independent coordinates which must be known to completely specify the position and the configuration of the dynamical system. So like as only x-axis, that is the kinetic energy half mvx square, y-axis half mvy square, two axis half mvx square plus half mvy square. So half mvx square plus half mvy square plus half mvz square. So maximum possible rotational degrees of freedom half ix omega x square plus half iy omega y square plus half iz omega z square. So this is the important for JEE purpose, not NEET purpose. So monoatomic, please remember the total number of degrees of freedom, because NEET needs the result and JEE also, so does not needs the any derivation, this kind of. So that monoatomics F is equal to F is equal to degrees of freedom, so small f equal to 3. Diatomic F is equal to 5 and 3 translational, 2 rotational. If temperature less than 70 between diatomic molecules, then F is equal to 3. If temperature between 250 Kelvin to 5000 Kelvin, then F is equal to 5. If temperature less than greater than 5000 Kelvin, then F is equal to 7. 3 translational plus 2 rotational plus 2 vibrational. So Maxwell equipartition of energy, this terms equipartition means total energy is converted into equal degrees of freedom. So what is this? So like as the gas has F degrees of freedom. So 1 degrees of freedom, energy associated with each degrees of freedom is half kBT. So if degree of freedom of a molecule is F, then total kinetic energy of the molecule U is equal to half kBT. U equal to half kBT. And internal energy, the internal energy of a system is the sum of kinetic and potential energies of the molecule, and U is equal to, for an ideal gas, U equal to F by 2 nRT. So let us take some examples, very, very interesting examples, solved examples. Example 1, a light container having a diatomic gas enclosed within its volume with velocity v, mass of the gas is capital N and number is N. What is the kinetic energy? And F by 2 nRT. So F is 5 for diatomic gas, right? And so what is the kinetic energy with respect to ground? This is a very interesting question. So this is the JEE purpose question. So kinetic energy of the gas with respect to ground equal to kinetic energy of center of mass with respect to ground. This half mv square nothing but, and kinetic energy with respect to center of mass, this is nothing but 5 by 2 nRT. So this is the approach to solve this type of problem. So this problem also can be solved another method. Please solve the mass empirical formula and then derive the half mv square and the 5. Then you can write that 5 by half mv square and the 5 by 2 nRT. So this is also example 2. And these are very important and famous examples in JEE purpose. Two non-conducting containers having volume V1 and V2 contain monoatomic and diatomic gases respectively. Okay. They are connected as shown in the figure. This is the figure. Pressure and temperature in the two containers on P1, P2 and T1, T2 respectively. P1, T1 and P2, T2 respectively. Initially, stopcock is closed. If the stopcock is opened, then find the final pressure and the temperature. So please look at the picture. If you look, then you can easily say The gaseous equation PV equal to NRT, no. So what is the unknown quantity? What is the unknown quantity in this picture? For vessel 1, N1 is unknown. Vessel 2, N2 is unknown. So, just so N1 equal to P1 V1 by RT1 and N2 equal to P2 V2 by RT2. So number of moles, we know that moles are total number of moles are conserved. So N equal to N1 plus N2. So first N equal to, when we adding the final mole, so also add the volume. So pressure is not changes. So V equal to V1 plus V2. So P of V1 plus V2 by RT is equal to P1 V1 by RT1 plus P2 V2 by RT2. Because P1 plus P2 is equal to P, so P common, V1 plus V2 by RT is equal to P1 V1 by RT1 plus P2 V2 by RT2. So this is the pressure. So how can we conclude the temperature? Yes, temperature is formed by energy conservation principle. So from energy conservation, 3 by 2 N1 RT1 plus 5 by 2 N2 RT2 is equal to 3 by 2 N1 RT plus 5 by 2 N2 RT. So if we solve that T, 3 P1 V1 plus 5 P2 V2 R T1 T2 divided by 3 P1 V1 T2 plus 5 P2 V2 T1. So just take this term, and if we this, and we can write the final pressure according to P. So P equal to 3P1 V1 plus 5P2 V2 by 3P1 V1 T2 plus 5P2 V2 T1 and P1 V1 T2 by plus P2 V2 T2 by V1 plus V2. So these are the some numericals for JEE purpose. So our next topic is indicator diagram. So what is the meaning? Indicator means which indicates. Which indicate? Diagram indicates. Which diagrams? The graph representing the variation of pressure or variation of temperature or variation of volume with each other is called to indicator diagram. So indicator diagram possibly three types: PV diagram, pressure volume diagram, pressure temperature diagram, or volume temperature diagram. So like this is the example of PV diagram. It is our big problem. We can know only one diagram, like as PV diagram is all just known as indicator diagram, but this is wrong. This is wrong. PV, PT, VT, because PVT, these are the three main functions to denote the gaseous system, to denote the thermodynamical system. So combining PV, PT and VT, these are the three quantities or three pairs to describe an indicator diagram. So thermodynamics. So what is thermodynamics? Thermodynamics is mainly study of exchange of heat between bodies and conversion of the same into mechanical energy and vice versa. Like as in winter, a cup of tea in our hand. So this is the heat exchange between system and surroundings. So thermodynamics is mainly the study of exchange of heat between bodies and conversion of the same into mechanical energy and vice versa. So what is thermodynamic system? Collection of extremely large number of atoms or molecules confined within certain boundaries such that it has a certain value of pressure, volume, temperature is called thermodynamic system. Anything outside of the thermodynamic system which energy or matter is exchanged is called surroundings. any observable quantity, any observable things, it is the part of which is part of universe, is called thermodynamic system. It is called thermodynamics system. And what is the surroundings? Surroundings is nothing but the outside of the thermodynamics system. So what is the types of system? Open system, closed system, and isolated system. So what is open system? A system is said to be an open system if it can exchange both energy and matter with its surroundings. What is closed system? A system is said to be closed system if it can exchange only energy, not matter, with its surroundings. An isolated system is said to be an isolated if it can neither exchange nor matter with its surroundings. So what is the zeroth law of thermodynamics? This is the thermal properties of matter. So what is the zeroth law? Like if two systems, please see the picture. B and C are separately in thermal equilibrium with the third one, A. So B is thermal equilibrium with A and C is thermal equilibrium with A. What is the thermal equilibrium? What is the terms of thermal equilibrium means? Thermal equilibrium means the temperature of these two systems are equal. Like as temperature of A is 22 degrees centigrade, then the temperature of B is also 22 and temperature of C is also 22 degrees centigrade. So this is the thermal equilibrium. So if two systems B and C are separately in thermal equilibrium with the third one A, then they themselves are in thermal equilibrium with each other. That means B is thermal equilibrium with A and C is thermal equilibrium with A. Then B and C are in thermal equilibrium. So equation of the state, the relation between thermodynamics variable PVT of the system is called equation of the state. Like as ideal gas system, PV equal to nRT. Or like as boil system, PV equal to constant. So work done by a gas. So work done means, so let P and V be the pressure and the volume of a gas. Okay. If A area be the piston, then force exerted by the gas, we know that pressure equal to force by area, so force equal to pressure multiplied by area. So F equal to P into A. Let the piston move through a small distance dx during the expansion of the gas. So work done. How we will find the work done? So work done equal to force into displacement. So dw equal to, so f dot dx. So f equal to pa dot dx. So what is the meaning of this term a into dx? A equal to area and dx is equal to displacement. Okay, so a into dx means volume of the system. So dv, so dw equal to p into dv. So w equals to integration of p dv. Area under PV curve gives work done during process. Any area. So like this, but so this is the area enclosed. Okay. So this is area. So initial volume is VI and final volume is VF. So integral lower limit to upper limit. So VI to VF, PdV equal to W. It is the work done by a gas. So different types of processes. First is isothermal. See, when we see the term, we will learn that about Boyle's law. Then we'll then we'll learn about that. Please. So T is constant. So PV equal to constant. So PV, TV and TP diagram. So this is a PV diagram, this is the TP diagram, and this is the TP diagram. So there is the exchange of heat between system and surroundings. System should be compressed. System should be compressed or expanded. So these are the four parts: isothermal compression, isothermal expansion, adiabatic compression, and adiabatic expansion. So these are the four terms in our syllabus according to compression and or expansion. Very slowly so that there is sufficient time for exchange of heat, keep the temperature is constant. So the isothermal process is actually very slow. Actually, is a very slow process. So what is the PV slope of PV curve in isothermal process? PV equal to constant. So dP by dV is the slope of a PV curve. So dP by dV equal to minus P by V. So dP by dV equal to minus P by V. So what is the work done in isothermal process? So please remember this formula because this formula is very important in the NEET purpose. So W equal to nRT ln Vf by Vi. If we convert ln from log base 10, so we can use the formula W equal to 2.303 nRT log base 10 Vf by Vi. So this is the expansion. Please see the graph. This is the expansion process Vi to Vf, and this is the compression Vf to Vi. So this is the isothermal expansion and this is the isothermal compression. So internal energy of the isothermal process. So we know that U equal to function of only T. Internal energy means that does not depend pressure, any kind of volume. This is depends only temperature. So temperature is constant. So dt is 0. So delta is also 0. So isochoric process or isometric process, V equal to constant. So pressure in change in volume is 0. So P by T equal to constant. So work done in isochoric process, since change in volume is 0, so dW equals to 0. So indicator diagram, this is the indicator diagram of the isochoric process PT, VT and PV diagram. Change in internal energy, isochoric process F by 2 nR delta T. Heat give me isochoric process delta Q is equal to delta U is equal to F by 2 nR delta T. So our third process is isobaric process. So pressure remains constant in isobaric process. So P constant. So V by T equals to constant. So V proportional to T. So these are three indicator diagram. First PT diagram, second PV diagram, and third in Kelvin diagram. So work done in isobaric process delta W equal to P delta V. So V final minus V initial so equal to nR T final minus T initial. So Q delta U is equal to N CV delta T. CV is the specific heat of a gas when the pressure volumes remains constant. And also another part is there where this is called CP. CP is the specific heat of a gas when pressure is constant. So heat given in isobaric process, so delta Q is equal to delta U plus delta W according to first law of thermodynamics. So according to first law of thermodynamics, total heat equal to total internal energy plus work done. So delta Q equal to N F by 2 or delta T plus P Vf minus Vi. So this is N F by 2 or delta T plus N R delta T. So cyclic process. What is cyclic process? In this cyclic process, so work done equal to area under PV diagram. Change in internal energy is same. So dq is equal to dw. If the process is PV curve is clockwise, then the net work done is plus V and vice versa. So this is the minus and this is the plus work. Please realize the line, if the process on PV curve is clockwise, then the net work is plus V and the vice versa. So let us solve some problems. So this is the problem. Find out the work done. These type of problems are very, very important. Find out the work done in the graph. Also draw the corresponding PV curve and PT curve. So at first solve, this is the, since PV curve area under the cyclic equal to work done, therefore work done by the gas equal to P0 V0. So because these are cyclic processes totally, then this is the work done equal to PV. That means the initial position is P0 and the initial volume is V0. So the work done is P0 and V0. So let us solve another problem. PV curve of a cyclic process is shown below. Number of moles of the gas is in the final total work done. Very important problem. So final volume is V0, final temperature is T0, final volume is 2V0 and final temperature is 2T0. So since path AB and CD isochronic, because why this is isochronic? AB and CD. Volume pressure does not change. Okay. So W if BC equal to nRT ln VC by VB, VF by VI. So nRT ln, nRT means 2T0, VC by VB. So 2N T0 ln 2 and WDA, DA lines. This is the lines. So this is the lines. So AB and CD isochronic, so therefore work done 0. So and during AB and CD and pressure BC and CD are isothermal. So DA part is isothermal part. So VDA, so this is equal to nRT0. So this is the initial temperature when according to DA line, then the temperature is T0, nRT0 ln VA by VD. So is equal to minus nRT0 ln 2. Because this is the anti-clockwise, so this is the negative sign appears. So total work done equal to WBC plus WDA. So 2 nRT0 ln 2 minus nRT0 ln 2, that means nRT0 ln 2. So let us talk about the first law of thermodynamics. The first law of thermodynamics is the law of conservation of energy. It states that if a system absorbs dq heat and as a result the internal energy of the system changes by du and the system does the work dw, then dq equal to dw. But dw equal to pdv, so dq equal to du plus pdv. This is a mathematical statement of first law. So dq is the total energy, then it divides between two parts. Du, it is the total internal energy, change in internal energy, and the total work done. And this thermodynamic state first law is the conservation of energy. Let us take an example. This example. The internal energy of a monoatomic ideal gas is 1.5 nRT. 1 mole of helium is kept in a cylinder of cross section 8.5 centimeter square. The cylinder is closed by a light frictionless piston. The gas is heated slowly in a process during 42 joule, total of 42 joule heat is given to the gas. If the temperature rises through 2 degrees centigrade, find the distance moved by the piston. So change in internal energy, what is 1.5 nR delta T, 1.5 N means 1 mole, R means 8.3, this is the value of the universal gas constant, and T means 2 Kelvin. Okay. So this is 224.9 joule. So heat given equal to 42 joule. So work done from the first law, you know that delta Q is equal to delta U plus delta W. So delta W is equal to delta Q minus delta W. So 42 minus 24.9 joules. So that means 17.1 joule. So if the distance moved by the piston is x, so delta W is equal to pressure into volume. So from according to this equation, volume equal to cross-sectional area into distance. Okay. So from delta W is equal to 100 into 8.5 into x. So from according to this equation, we can easily calculate x equal to 20 centimeter. So another example, a sample of ideal gas F is equal to 5 is heated at constant pressure. If an amount of 140 joule of heat is supplied to the gas, find a change in internal energy of the gas, the work done by the gas. Suppose the sample contains n molecules, so delta Q is equal to delta U plus P delta V. So delta U, PV is equal to N naught T. So P delta V means N is constant, R is constant. So only changeable quantity is delta T. So delta U plus NR delta T. So delta U plus 2 delta U by small f. So f is a degrees of freedom. So sample of ideal gas where f is equal to 5. So delta U equal to n by 2 f by 2 r T2 minus T1. So n f by 2 r T2 minus T1. So this is the part. If we calculate, this is equal to f by 2 plus f delta Q. So this is the 100 joule. And according to first law of thermodynamics, delta W equal to delta Q plus delta U. Delta Q is equal to delta W plus delta U. So delta W is equal to delta Q minus delta U. So that means 140 joule minus delta U means 100 joule. That is the 40 joule. So these are last topic, efficiency of a cycle. So efficiency means total mechanical work done by the system of the whole process divided by heat absorbed by the gas. This is the only positive quantity. So this is also can be written by this also formula, area under the cycle in PV curve divided by heat injected to the system. So let us say in our first part we can we say that the Joule's law is totally wrong. If Joule's law is correct, then the total energy will convert it into work. But according to thermodynamics second law, Kelvin Planck statement and Kelvin Planck statement and Clausius statement say that no engine is possible to convert the heat totally to the work. So efficiency of the cycle is cannot be 100%. Okay. So this is the ultimate verification and ultimately proof that Joule's law is totally wrong. So eta equals to 1 minus Q2 by Q1 for heat engine, and for Carnot cycle eta equal to 1 minus T2 by T1. And T1 and T2 are respectively source temperature and the sink temperature. And the temperature of the source is very high, whereas T1 is very high and T2 is the sink temperature. This is a very low. So let us take an example. Yes, this is example. N moles of diatomic gas undergo the cyclic process ABC as shown in the figure. The temperature at A is equal to 320. Find volume at C, maximum temperature. So since triangle, those let's the triangle OAV0. OAV0. Oh, this is the point O actually. Yes, it's the main point. O. And OCV is the O point. OCV. Similar, therefore, so therefore 2P0 by V equal to P0 by V0. So V equal to 2V0. Since the process AB, so where is AB? This process. This is the AB. So what is the process? This process is AB is isochoric because volume is constant in this process. Because how will define? Because this is parallel to the y-axis. Hence the V is constant. Therefore, since the process AB is isochoric, since PA by PP is TA is equal to PB by TB, so TB is equal to 2T0. Since BC is isobaric process where pressure is constant, so TB by VB is equal to TC by VC. TB by VB is equal to TC by VC. So TC equal to 2TB is equal to 4T0. So this is a cyclic process. So delta Q is equal to delta W area under the cycle. So the half into base into height is the triangle. So half P naught into V naught. Since delta U and delta W both are negative in process CA, so delta Q is negative process CA and it is rejected by the process CA. So delta Q of CA is equal to delta W of CA plus delta U of CA. So if we calculate minus half of P 0 plus 2p0 into v0 minus delta u is equal to f by 2 nr delta t. So f is equal to 5. So 5 by 2 nr tc minus ta. So this is a part is equal to, if we calculate, n is 1 mole. So this is equal to 9 p naught v naught. So this minus term indicated the heat is injected. So eta is equal to efficiency by the cycle. So work done by the gas divided by heat injected. So in eta is equal to P naught V naught by 2. This is divided by Q injected into 100. So Q injected is equal to total that QAB plus QBC. So this is, if we calculate 5 by 2 A naught 2 T0 minus T0 plus 5 by 2 A naught 2 T0 plus BC. So another part PV diagram also. So 2 P naught into 2 V naught minus V naught. So if we calculate A naught T is equal to also PV, so 19 by 2 P naught V naught. So this is a 100 by 19 percentage. So please remember also the terms molar heat capacity of ideal gas in terms of R. CV is equal to for monoatomic gas F is equal to 5. So this is the standard relations. So Cv is equal to 3R by 2, Cp is equal to 5R by 2, and gamma equal to 5 by 3, that means 1.67. For a diatomic gas, F is equal to 5, so Cv is equal to 5R by 2, and Cp is equal to 7R by 2, and gamma equal to 1.4. And for triatomic gas, F is equal to 6, so Cv is equal to 3R and Cp is equal to 4R. Note for carbon dioxide, F is equal to 5 because triatomic molecules are two parts, linear triatomic molecules and non-linear triatomic molecules. So CO2 is equal to linear, so F is equal to 5. So gamma equal to Cp by Cv, so 4 by 3, that means 1.33. In general, Cv is equal to Fr by 2, Cp is equal to F by 2 plus 1 of R, gamma is equal to 1 plus 2 by. This is a very, very important relation, gamma equal to 1.1 plus 2 by F.